universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Well, hey, welcome to Sky Tour Radio. It's a wonderful wonderful July 11th, and 2021. My head's a little scrambled, probably because of that big solar flare we just had last Saturday. And we're going to talk more about that, and solar flares are going to be kind of a topic for tonight. But I wanted to welcome you to Sky Tour Radio. I am here tonight with, of course, our friend and wonderful person, Tara, who is going to bring us some wonderful questions and talk about some other things with the moon as well. And also we have Daryl Mason, of course, the astronomer's astronomer. That's what I call him. And he will be joining us to talk about the constellation of his choice for tonight using Stellarium. And I think you guys will probably be on the edge of your seat with that because he's really good at this. All right. So welcome, Tara. How are you? How's it going down there?
Doing great. Thank you. Glad to be here. How are you guys?
Oh, great. Daryl, how you doing?
I'm fine. You?
I'm fine. Thank you. You'll notice Daryl doesn't have a picture showing it. You know why that is? Because he's hiding and he's in a bunker. Okay. And he can't show the bunker or he'll have to kill us.
Yeah.
Uh-oh.
Yes. And that would be sad, you know.
I used to be so pretty.
Yeah, that's what he says. That's hilarious.
We all did.
Well, some are still, but we'll just let that go. I'm not saying to me. So look at welcome to Sky Tour Radio again. And Amanda is taking the night off because actually she's not feeling well. So we unanimously decided for her. She would have done it, if we wanted her to, but she was just not in really good shape tonight. So we kind of sort of ordered her to take the night off because you have to do that with her. It's like the second time in 4 years.
That's crazy.
That she asked, to consider that we let her off for the evening. And it's like, you have to ask after 4 years? No, you don't have to ask. And of course,
Amanda's a trooper.
She is,
She's awesome.
Without a doubt, probably one of the most important people to Sky Tour Radio. She has kept us going and moving in the right direction for years. So you want a day off, Amanda? Seriously? You have to ask? It just doesn't make sense. But you know what? It's okay. So we wish her the best. She's probably asleep by now. And she will, when she wakes up, I think she'll be feeling a lot better. So that said, talking about sleep, as an astronomer, I don't get a whole lot of it, as many of you know. And we did a stream from Sky Tour Live Stream West. I forget, when was that, Daryl? Because you joined me.
It was last week.
Last week sometime, right?
Yeah.
Yeah, and I had this real awful thing happen when we were actually getting into the stream before. I think Daryl had already joined. I noticed that the telescope was no longer working right. And it's like, what happened now after all this we've gone through? Well, it turns out that on July 3rd, we ended up with a very, very powerful solar flare. And that solar flare spewed a tremendous amount of energy, very high frequency energy, into our magnetic field, and that energy went down through the poles, struck the earth all over the place, and that the majority of these X-rays hit out in the Atlantic Ocean, but then it tapered off westward and also hit Arizona. which is where the telescope is located. And that, I believe, is the reason when I started the telescope, it basically just said, huh, where am I? It didn't have any idea where in the sky it was looking. And I had shut it down the previous time I tested it, and it knew exactly where it was. It was functioning perfectly. It lost everything that it's supposed to have programmed into it. However, it's still physically aligned, and I could actually still stream with it because I sort of had an idea where it was pointing, and I had an idea what it was looking at. So we actually moved it around. And Daryl, you were with us. So we actually saw some views of the Milky Way's dark rift in the Milky Way and these gorgeous black clouds of dust that are in the Milky Way silhouetted against the many, many thousands, hundreds of thousands of stars behind.
Oh, yeah. It was great. It was like a whole new view into things.
Wasn't it, though? It was just so pretty. I could not believe how beautiful it was. And I was really happy that Daryl was there to see it, too, because he appreciates these things. So I thought it was really, not that you don't, you all do, but it was especially important that he be there because I wanted him also to see the new mechanisms, the new programs, the new approach to Sky Tour live stream. We've actually kicked it up one heck of a notch. I got to tell you that. Yeah. We increased the capability of the telescope by 25 times. We have increased the optical speed of the system tremendously. And it actually has, I was nervous, I got to tell you, about doing the first stream like that because I was kind of doing it off the cuff. I wasn't really, planning a stream. And then I decided, you know what, we're going to stream. And Daryl's like, okay. And that's it. We decided to just do it.
I thought it was great. It was wide field astronomy, which I always loved wide field anyway.
Yeah.
And it was just like a whole new look at things. And I think there's going to be a little bit of a learning curve involved in getting over it. It was almost like using binoculars live.
Yeah. And that's a really good way of putting it. And to think about how much we actually see. Okay. The moon is half a degree in diameter. Okay. And in the horizontal direction, we actually have 4 full moon widths of view that we can see. And in the vertical diameter, we have 2.5 moon widths. So like 1.5 degrees by about 2 degrees, a little over 2 degrees, actually. So we're seeing these very wide swath of the night sky. It is unbelievable to see that. And I can't wait to get that scope aligned with the sky again because I want to show you guys these incredible nebulae and things that are out there. Oh, it's just crazy beautiful. And I can't get enough of it myself. Tara.
I'm sorry, go ahead.
No, it's okay. Go say what you're going to say because
it was sort of a potluck thing. The telescope didn't know where it was pointing, and it was like going fishing, and
that's what it was, yeah.
Or like what's his face, and you never know what you're going to get, Forrest Gump. And we just we're trolling around the Milky Way down toward the middle of the galaxy. We were seeing all sorts of star clusters and nebulae, and a lot of dark objects, which are really fascinating, so-called Barnard objects.
Yeah, that's right.
It was just great.
Yeah, and there'll be more of that because we're planning on doing that again. Actually, if it's clear out there tonight, we're going to do it again. So you can join us if you like, Daryl. If I'm going to do it, I'll let you know.
Sure. Sign me up.
Okay, and Tara, you're always welcome, but it would be starting at 9 p.m. your time. Okay, because I'm going to start at midnight here. And last time we did this, when Daryl was with us here, we just figured, okay, I'm just going to go a little while. Yeah, a little while. Yeah, that works out. Those who know
Not
me
you.
know. Yeah, exactly.
Not you.
A little while turned out to be like from midnight to 3:30 a.m. Stream, and I didn't want to stop. I had to stop because my body was shutting down for the night. So it was like I was going like this. I was like my body was gonna like batteries are running low. So it was really cool, and so we'll be doing that again. If it's clear tonight out there, we'll do it. It hasn't. Tara's looking now. Cloudy.
It's a little overcast, a little cloudy, partly.
Okay. Well, it's the monsoon
Been
season.
storming.
So
It stormed
Yeah.
yesterday.
Monsoon acts like it's trying to break here. It hasn't rained in several days. It has tended to cloud up. They're calling it sunny, but it's kind of hazy because there's a lot of smoke from forest fires out west.
sure.
So you might still get a view tonight.
Well, maybe. I'm very careful with the telescope though, because I know there was a haboob that came through a couple days ago. Or was that yesterday? I can't remember.
Yesterday.
Haboob
Mhm.
is a dust storm, guys, and it doesn't take much to lift the dust off the desert and get it airborne, and then it goes really, really high altitude and just lingers. And since that was yesterday, it almost sounds like a bad idea to try to do this tonight because there's going to still be high altitude dust filtering out of the sky. So the roof is on the observatory right now, and I really want to try it, but it depends. I can tell if there's dust in the air. I don't have a dust meter on the telescope, not yet, but I do have a seeing and transparency monitor, which can tell me how clear the sky appears and how steady the sky looks. It's built into the new system that the telescope has on it. So we can use that and do tests. What you do is you bring the telescope down low and you look at a star that's kind of nearer the horizon. And then you put on this monitor, and this monitor is going to study the starlight. And it tells you just by how much the sky flickers, how much the star flickers, that's going to tell you about the seeing. The transparency is when you know which star it is and you know how bright it should be at that elevation. And if there is any kind of significant, what we call extinction, where the light is extinguished, by the fact that we're looking through stuff like dust, then we're going to get a lower transparency value. So this is part of calibrating a telescope for real when you're actually trying to do some really good stuff. And so that's what we're doing. It's just
I thought Haboob was the kid on Johnny Quest.
No, that's Haji.
Oh, sorry.
Remember Haji?
Yeah. I'll be here all week, folks. I just flew in from Chicago and boy, are my arms tired.
Arms tired over.
All right. I'm going to see myself off to the corner now.
Yeah, I don't think so. But based on our UAP report that the government released, maybe you would then be considered that airborne clutter, Daryl. Which includes birds, balloons, drones, or other airborne debris. Would you be considered the airborne debris?
Sure. Why not?
I guess, right?
Yeah.
Yeah. So if you guys get a chance, it would be great to have you come on out and check out SkyTour Livestream West. If you haven't become a member, do so. It's free. And our new system is such that when we take a photograph, it's immediately shipped up to the cloud right then and there. And so as soon as the picture is done, it goes up to the cloud and becomes available to all of you. I'm working on getting a public directory up there so that you'll be able to get access by date to all the imagery that was taken in the telescope, including the stacked images. And we've talked about stacking before, but I just for purposes of giving an idea, when we look at pictures taken with telescopes, you say, wow, what a beautiful photo. What you may not realize is that it was actually more than one photo in many cases. And so what happens is you take one photo and then you take another photo from the same place and another and another and another. And now you have all these layers of the same photo. Seems like a waste of time, doesn't it? However, each time, if my fingers were a nebula, okay, the nebula might be somewhat faint here, but when you put the other picture, if you put the other photo of the additional nebulae on top of that photo, then these nebulae get more defined and better looking, and all the noise around the nebula is going to get rendered more random, and that helps the nebula stand out against that noise. And when we do that, that process of literally stacking these images on top of each other, that's exactly what it's called. It's called image stacking. And when I was younger, I didn't know anything about it, and I would just take a long exposure. I would take a 20-minute exposure of an object. And then I realized, wow, well, boy, that was really hard to do because I had to actually guide the telescope because it's not perfect. The telescope follows the stars, but it's not perfect. It goes back and forth periodically. It's called a periodic error. And so you have to actually have a reticle, okay, which is the crosshairs, and make sure that you take that star you're using as a guide and put that down in the corner and you just hold it right there. And you have a little handset and you're making sure that that doesn't move. If it moves a little bit, you've ruined the shot. If you're 10 minutes in, you've ruined it, it's gone. Okay. So with stacking, you can kind of take shorter exposures, not necessarily shorter, but you can take them and make them shorter. And if you have a camera that actually has a capability of having what's called a gain parameter, GAIN, gain, then you can actually increase the sensitivity of the camera. And the problem with that is there's a cost to that. You get more digital noise in your final image. In other words, more pixelation here and there. However, when you stack, that pixelation can actually get averaged out. And there's methods to actually get rid of all the noise, which I use all the time. I show people how I get rid of noise in my shots that I take with SkyTour Livestream, and the shots look beautiful. They look like they're large observatory photos, and the reason is because there's so many tools available to everybody to do these things. It's really just so beautiful. But when we tried to stream that other night, that was the first anomaly I ever saw with that telescope. And it was on July 3rd. And it was on, no, not July 3rd, but on July 3rd, there was a large eruption on the sun. And it sent an extremely large, say high amplitude, high energy amounts of radiation toward the Earth. And that radiation was hitting the Earth 8 minutes after it was released from the sun. And it's amazing because, that radiation actually, just give you an idea, it looks like that. That on the upper right corner, that weird plus sign, that's actually a spike from the flare. It was actually on the limb of the sun, the edge of the sun. And it still reached us. And the magnitude of this solar flare was so high that it was up in what's called the X class range. And that's a little preview of what we're going to talk about because we're going to be coming back to this very shortly.
Cool.
Yeah, that was the flare. So it's pretty cool. But the telescope got hit by that flare, as anything gets hit, because what happens is when the flare gets to the Earth, it strikes around the poles. The high energy particles spiral down, and they go down into the bedrock. And the bedrock can be conductive. And that conductive nature of that bedrock is what blows out power stations, what causes spikes and surges on the grid, and can take us down, as it has in history many times. Which is why an exposed surface grid just makes no sense to me. It never has, and I don't get it. It's just the way it is.
Carrington event.
Oh, yeah, well, actually, we're going to talk about the Carrington event a little bit later. Yeah, we will indeed.
Okay.
Yeah. No, that's fine. But, I just think it's pretty outlandish, that we actually have to deal with this stuff, But
yeah, well, I found it interesting, that image you showed of the flare.
Yeah.
It's an X-class flare, and it's just coincidence that it looks like an X. I guess it saturated the sensor or something.
Correct. Yeah.
Yeah. But I thought that was pretty neat. It's like saying, hey, I'm an X-class flare.
I know, right? X marks the spot, But, before we get to our flare discussion, I did want to mention a couple other things, and that is that today was kind of a historic day because Richard Branson actually went to the edge of space today in Spaceship Two, which is part of his Virgin Galactic spacecraft fleet. And it was really an amazing event because he went with basically a full complement of a crew on his spacecraft. There were 2 other astronauts with him and 2 pilots. So it was actually pretty interesting. He sat in a regular passenger seat, and here he is in his passenger seat. All right, and you can see the other astronauts behind him. So it was really quite an interesting flight. Now, when he first set up, the way it works is that this ship that you see in the middle there, the one on the left and one on the right, that's connected through the middle, that's actually the mothership. The mothership is named Eve after his mother. It's a pretty interesting, and it took off at 10:30 this morning. I watched the whole thing and got all kinds of imagery, and it separated from the mothership after about a half hour in the air, and then it actually once it separated. Okay, here's image of it on its way down the runway to take off, and then as the ship, which you see right in the middle there, we're looking at it from literally one of the pylons on the Spaceship 2, which is the thing in the center. When it started to disconnect, this is the scene that we saw. There's the mothership up above, and now you see the Virgin Spaceship 2 dropping from the craft above. And that would be nothing. It would just glide back to the ground if otherwise it didn't have this engine. And it actually turned on this large rocket engine, which took it up to 282,000 feet. That's 53.4 miles. Technically, as Daryl pointed out before we went on the air, technically that's just past the edge of space, which is defined as 50 miles. Correct, Daryl? Yes.
Yes, I'm sorry. Yeah, it depends on who you listen to. The U.S. definition by NASA, the U.S. military and such, is 50 miles. This doubtless goes back to the days of the X-15 and such. The international standard is, unsurprisingly, 100 kilometers or 62 miles. It's called the Kármán line.
Kármán, yeah. Yeah, and this is interesting because, if you look at this image here, at this point in this image, you can see in the upper right corner, you can see the altitude. It's 46,000 feet. At 46,000 feet, look at the sky. It looks deep blue leading to black up above. Isn't that crazy? So you're above way more than half the air on the Earth. You're actually above half of all the air on the Earth when you're just above 25,000 feet. So at 46,000 feet, you're literally around twice as high as a average airline flight. At least, maybe if they fly at 22,000, you're a little higher, more than twice that height. Then you have the ones that fly at 36,000, 34,000. And so only a little bit higher and your sky would look black up above. Isn't that crazy? But then when you get to 282,000 or so, then you see that the sky looks fully black because you are now above nearly, if not all, well, not quite all the air on the Earth. This is the photo. Now these, if you look at the wings on the side of the Spaceship 2 here, and I'll go back to this photo for a minute. Those wings on the side, the vertical, well, the structures that go from the word Virgin backwards, and then they have the fins. Those whole things rotate upwards, like and like a badminton birdie. The thing comes down on its belly like that, right? So here it is, as it's made its way into orbit. The rocket engine is off, as you can see, and like the badminton birdie, these wings on the side are going to fold up into the air. Well, there is no air, I should say, up into the sky, and they're going to end up doing their thing. And what I mean by doing their thing is they're going to send the spacecraft into a flat attitude, which is this. Here the wings are now up. You can see them there. and you're looking at the top of Spaceship Two right there, and it's going to fall down vertically like this. And as it falls, those vertical wings actually slow it down and add some significant drag, which is kind of cool. And then this is another view of it. Okay, here it's back at 46,000. All right. And then what happens is those wings end up getting rotated down again into this horizontal position. And now it's back to being an airplane. And once it does that, it's now flown to the runway like any other aircraft. Right. And of course, Branson was looked like he's about to throw up, but he actually made it. Pretty cool. I'm glad he made it. And then from a distance, here is Spaceship Two and a chase plane together. And then the Spaceship Two came in to land. It's a really odd looking bird. There's no doubt about it. And then it finally landed. And then the fleet of Land Rovers came up to this thing because Land Rover's one of their partners. So they got lots of airtime. Oh, yeah. And they ended up making their way out and back to the home base where, of course, Branson's, wow, I get it, pretty cool.
When they were at the apex of their flight, they inverted the aircraft so they could look out the windows and get a view of the Earth. And that's when they all unbuckled. That's when they unbuckled their seatbelts and floated around in 0G.
Yeah, and they floated around in 0G for a shorter amount of time than you would on the Vomit Comet, which you could take out of Las Vegas and go for a flight. But there'll be more on that when we get back. Right now, we're going to take our first break. This is Sky 2 Radio with Tara down below and Daryl right there. We shall return. Be right back.
Perfect.
Hey members, the new KGRA-DB app is now available on iOS and Android devices. Gain on-demand access to any KGRA-DB programming. Download any show directly to your mobile device to listen or watch on the go. Go to the App Store and search KGRA-DB.
I don't want to talk about it.
I don't want to talk about it.
Families don't have to talk about everything, but they should talk about how to plan for an emergency. Get tips and resources to make your family's emergency plan.
Welcome to the new KGRA digital broadcasting website, thekgradb.com. Here you'll find great new content, including the KGRA Classics, great shows from our archives. You'll be able to see the show times and information so you can see what show is currently on air. The on-air live button. So just go to this section and you'll be able to hear the show live with exceptional sound quality. We also have the Vault section. Make sure to subscribe to get access to great content and special features. We have the make content for our latest news and events, so make sure to sign up and you can be part of our forum. So make sure to check out the new KGRA digital broadcasting website, thekgradb.com. We look forward to seeing you there, and we hope that you enjoy the new website.
Hey, welcome back to Skyter Radio. This is Mark with Tara down there and Daryl over there. And just because she's down there doesn't mean that she's like relegated to like second class. Okay, she's actually a superstar here. She's got a lot of pull, and hopefully she'll let me keep my job as a host on Skyter Radio. Because she's so powerful here. Isn't that so, Tara? I mean, come on.
Whatever you say, Mark. Absolutely.
Come on. Yeah. So one of the things that we were talking about was how interesting it was that that Richard Branson took off and landed successfully and safely. And it harkens back to the time when space flight was actually a lot more risky than it is now. Yes, it's the most dangerous job you can ever have. Going to the space station, everything wants to kill you. Your space capsule, if it loses its atmosphere, you're dead. If the ISS gets hit by a micrometeorite in the right place, you're dead. So it's all like playing with the numbers and statistics, the probability that things can happen. The space station's already been hit by debris, and the solar panels have been damaged by meteorite strikes on the solar arrays. So that's pretty bad. That's pretty bad. But at least they haven't been hit by any kind of a solar flare that could do damage to them on the space station. We showed you this picture before of the solar flare from July 3rd. This was an X-class flare, and we're going to talk a little bit about those different types of flares. There's different levels of flare, okay? You have an A-class flare, you have a B-class flare, a C-class, you have an M-class flare, and then you have the X-class. Now, A-class flares are an entire set of magnitudes in intensity below the X-class flares, and each of these flares have a designation within their category, so that an A-class flare goes from 0 to 9. Does that sound familiar to you? With our stellar classification, we talked about how you actually have things like you have an A-class star, A1, A2, B0, B3, B9, okay, that kind of thing. Well, it's the same kind of thing, but in terms of flares. And the interesting thing about the flares is that the X-class is a special category unto itself, because the X-class flare has a ability to go beyond 9. So it can go between, it can, like, you might have a M9. You can't have an M29. X-class, you can have an X-class flare that goes up to 40 or more. And we have had those. And so they can exceed the number 9 in intensity by a wide margin. But in terms of the flare that just happened Saturday, on July 3rd, that was an X 1.59. So just over the X1, right? It's not the highest, but it was certainly many times more energetic than an A or a C-class flare. How energetic? Well, it was equivalent to 100, more than 1 million 100 megaton bombs. That's actually pretty high intensity. And that's one of the lowest intensity X-class flares you can have. So that's pretty high, And flares release energy, okay? They release these high energy radiation, okay? So that's a flare. It's electromagnetic energy coming towards you. But they can also be followed by debris, stuff, star stuff, as Carl Sagan would say. The star stuff can come sailing toward us as well. And those actually have a special name. Those are called CMEs, or coronal mass ejections. And that is a large amount of material. It is high energy plasma particles that leave the sun at a high speed. They don't leave at light speed. Okay, they leave at a little bit less than light speed. So when the flare gets here in 8 minutes. That's how long it takes light energy to get here from the sun. But the particles actually take substantially longer. They don't get here in minutes. They actually might take about 20 hours to reach us. And they're going to have a lot of energy and a lot of disruptive capability. We've been struck by some of these before, these coronal mass ejections, and it has disrupted everything, and it does something to our magnetic field too, which makes it difficult for satellites to run properly. And we'll talk about that a little bit. But the particles that are streaming to us are this high energy material that's coming from the sun. And because it's slower, we have some warning. But, typically it would be about 20 hours, but it hasn't always been that way. Daryl mentioned earlier in 1859, he mentioned the Carrington. No, he didn't mention in 1859. He mentioned the 1859 Carrington event. Okay. Carrington was an astronomer. He was actually an amateur astronomer. And he saw this large flare on the sun. And it was the largest geomagnetic storm ever seen. And it was the energy, the coronal mass ejection that came from this flare, because they're often accompanied, one goes with the other sometimes, arrived here at the Earth 17.6 hours later, well ahead of the 20 hours. And they figured that, well, there had already been a coronal mass ejection before this, and it kind of paved the way for the next one to come by and actually make its way out past the other one and get here in record time. But that's an example of one that actually only disrupted telegraph systems. There wasn't a power grid per se to disrupt back then other than telegraphs. So, but it was of import anyway, right? Well,
hey, it set telegraph lines on fire and telegraph offices all over the place.
Yes, it did. Yes, it did. But in 1972, there was a real famous coronal mass ejection and flare that actually reached the Earth much faster than the Carrington event flare. It got here in just like 14.6 hours. I mean, that's very fast for something that's not, not moving relatively fast compared to the actual light speed radiation. Okay. And that does indicate really fast moving particles. And it measured as an X class flare at X 5.6. Okay, so remember it goes X 0 to 9. Well, this was X 5.6. But in totality, this 1972 eruption and CME and flare looks like it might have actually been an X 20. Okay, an X 20. And the Carrington event was probably an X 15 to 18 level event in itself. So, and during this 1972 attack by the sun, it was noted there were many serious disruptions, and some were actually very serious to the point. And I actually remember this. I remember this because they didn't know at first what had happened, but the satellites that detect nuclear explosions. Okay, in other words, nuclear explosions that might be set off by an adversary or something, they actually produced false readings all over the place. And they thought that nuclear bombs were exploding in a bunch of different places. Whoa, that's pretty bad. Only through the quick thinking. And I remember this controversy because they were very close to thinking that there was somebody attacking somebody on this planet. And the military was very quick to start working the data and figured out that these all happened sort of at the same time. And it seemed like maybe this false detection scenario was at play. Luckily, testing it and calling the heads of other nations, they realized, yeah, this is a false detection. So that, see, it can start wars, possibly. The other thing that happened was, and this is really dangerous. We had mines in the ocean, mines to like stop enemy shipping or whatever. Well, many of those mines are magnetically sensitive. And that means that if they feel the magnetic field of a ship coming nearby, they don't wait to make contact and go boom and then boom. Okay. They wait for the magnetic field to reach a certain level, indicating the ship is nearby, and then they explode. Well, guess what? They had up to 4,000 mines explode simultaneously. Okay, in 1972 when this happened, 4,000 all exploding at the same time. Isn't that crazy?
Ruh-roh.
I'd never heard that before.
Yeah.
Wow.
And basically, this is because of this 1972 event. And again,
that caused the famous blackout in New York City, didn't it?
That's correct. All right, and we're getting to the blackouts too. Good call. The satellites, of course, up in the orbit around the Earth were especially sensitive, as we talked about this defense satellites that were blinded and thought there was false readings. The flare event actually constricted the Earth's magnetic field. It pressed so hard that the magnetic field of the Earth was kind of pushed. And now the satellites were being exposed to all of this heavy radiation and unprotected by the magnetic sheath that it was previously protecting them. And when that happened, this actually caused many satellites to go into failure modes. A number of defense satellites failed outright. Other satellites just stopped functioning. Others had spurious readings, like the nuclear satellites, and so forth. But on the ground, you wouldn't have noticed much of this, okay? But at night, what happened was the Aurora Borealis and the Aurora Australis, the same thing, but down under, okay, down at the Antarctica. And these are normally confined, these Borealis and Australis are normally confined to the northern latitudes and the far southern latitudes. Well, they were visible at much lower latitudes than normal. And in the United Kingdom, as a matter of fact, one aurora was so bright it cast shadows. That's how bright it was. And I saw one of those in the late 80s here in Connecticut. We had an auroral center right over here, right over us here. I called the Aurora Alert Network, and I reported it and said, "Yeah, we got a radiant, a aurora radiant right over our head here." And this material came in, and I saw it streaming down. You could literally, if you haven't seen an aurora in your life, you know what? Do this. Go to a live aurora website. There's some in Finland and Norway, and you can just look at it online and explore and watch these auroras taking place in real time. You'll be surprised to see that these move across the sky like really fast sheets. And they're 90 miles away from you, and they're moving across the whole sky. They're moving, in some cases, at the speed of these high-energy particles. And that could be up to 300 miles per second that they're moving. All right? So when you watch these, you're going to be amazed and see these beautiful colors. Now, the colors are chemically based on the components of the atmosphere and so forth, but never mind that. Keep in mind at the speed they're moving. This is a visualization of how fast these particles are moving through space. They reach the Earth and they may slow down a little. So when you see them, arcing through the atmosphere and just sort of dragging out in curtains, keep in mind that what you're seeing is something that has been slowed down a bit, right? Because these things move at a really, really high speed. So I'm really think that we're talking about a really, really interesting event if you get a chance to see one. And having seen them for real, sometimes they change, they evolve over the night. The auroras that you'll see, like the one I saw in the late 80s. I was actually watching a movie with my nieces and nephews in a drive-in movie, okay, with relatives who all kind of went together. And I just happened to be bored by the movie, and I looked up and I saw this radially moving aurora moving down. I was blown away immediately, and I just ran out of the car, and everybody thought I must have had to go be sick or something. I ran out of the car, ran to a phone. I actually got the guy to let me use a phone because I didn't have a cell phone. No one did. And I called this Auroral Event Network and reported it, and the guy says, "What's that in the background?" I said, "That's a movie. Never mind." Okay. And so I saw it above the light of the screen and everything. It was so bright. And then after getting home, it was continuing, and it got better and better and better. I took pictures. I had all night. I was up taking photographs of this thing. And then I went and I got some sleep around 1:30 in the morning and woke up again at 3 in the morning. And I looked around the room, and it looked like surreal. It was a salmon pink glow all throughout the room. I'm like, what? And I thought, oh no, something's on fire. And I looked out the window, and everywhere as far as the eye could see, it was just this pink glow, horizon to horizon. It was stunning. And that was actually a special kind of aurora that can happen sometimes. It's a dome aurora that I was within. And it reminded me of a Star Trek episode called "For the World is Hollow and I Have Touched the Sky." And it was about a civilization that lived inside of an asteroid. And when they went to the quote-unquote surface, they saw just a pink featureless sky. And that was the walls, the edge of their world in this asteroid. But they were living inside the asteroid and didn't even know it. So it was really kind of a interesting story. Well, I felt like I was in that story, because it looked weird. It was unlike anything you've ever seen. No stars, just pink, pinkish red. What an amazing, like the color of this back here that you see. Okay. Just amazing. Now imagine that as an opaque, veil, horizon to horizon. You look through the trees, you see it. You look in the reflections of windows, you see it. Really amazing stuff. So
we had several tremendous auroras visible here in Colorado back in the late 90s.
Yeah.
They were really something to see. Saw a lot of green, saw red some too, which I guess is relatively rare.
Yeah.
You mentioned earlier about the big one in 72.
Yeah.
They were seeing auroras all the way down in the tropics.
Yeah.
Florida, down in Cuba, places like that. They were seeing them all over the world.
Oh, yeah. They were something. They were definitely something, And now, when you look at you consider what happens on the sun when this happens, okay? We saw this image, okay? That's taken from a solar observatory that's in orbit. But here's another one. How about that? Look at that large finger of plasma and high energy that's leaving the sun. This is also a flare with a coronal mass ejection. Okay. Those will get, if those leave the sun and they're heading in our direction, they can cause a lot of problems. They will disrupt our magnetic field. They will cause all kinds of problems with our power grid. Here's another one. This one here you're seeing, that's a solar flare in the upper left. And there's another one just below it on the left, and another one below that on the left. Okay, these are really powerful flares. Okay, here's another flare. These two are on the left side of the sun. You can see them, like it around the, I guess the 10 o'clock and the 8:30 locations. You can see them kind of on the disk of the sun there. Okay, those other streaks you see all around the outside, that's part of something we call the corona. That's the outer atmosphere of the sun. All right, and so what happens is in this one, you actually see something cool. This shows you a flare, which is right there, just right of center and above. And there you see loops. These loop streamers, these are interesting because they're actually following the magnetic field lines of the sun. And what's happened is the magnetic field of the sun has effectively been knotted up, okay, and bunched up. And if this location basically rips open effectively, then you're going to get some short loops that come out and come racing back down. And that's what we're seeing here. What's underneath here is actually a sunspot. Okay, the sunspots are typically beneath these flares. And you see the sunspot in the visible light. This is a different type of light we're looking at it in. Okay, and we're actually watching the flare here. This, in real time, you would look at this and not see anything really moving. It would take many minutes to see this loop change shape because the sun is so big and so far away. Same with this. This is what's called a hydrogen alpha view, looking at a different wavelength. And here is a large coronal mass ejection right of center and just above, and you see the flare event just above that. This is on the edge of the sun. But if you can see it, it means some of that energy is getting to you, and coming here. And that's part of the problem that we have. We have to manage that, and our power grid cannot handle it. Power grid can't handle that,
Did you ever see a show called Connections with James Burke? It was originally done by BBC, and it was carried in the U.S. on public television.
I do remember that show.
Yeah, excellent show. It opened, the first episode opened with the 72 solar flare and what it did to things. Shut down the power supply and everything.
Yeah.
Excellent program. It's on YouTube if you ever want to watch it. It's a classic show.
Yes, it is. Thank you, Daryl. That's good. And yeah, if you get a chance, look it up on YouTube. Connections is really good. Yeah. Another version of a flare here, you can see the sun is spewing a massive amount of material. Okay, the sun is on the right side of the screen, and you can see the disk of the sun, and it's almost lost in the amount of material that's coming off, and the flare event is just below the top there. So, and then here now we're looking straight on. It's like this part of the sun is facing us, and those are 3 sunspot groups. Okay, on the left you've got one, then you've got another one just to the right of that that's bright, another one to the right of that which is a little dimmer, and then to the right of that about the same brightness as one near the edge. So there's like 4 sunspot groups here, and there's a flare occurring in the second one from the left. And again, coronal mass ejections can follow. And if they head toward us, then if we're imaging the sun at that time, they might look something like this. Here is a coronal mass ejection from a flare, and the flare event is just below center. It's the bright white orange area. And here's a gigantic loop of material that you see coming off the sun. It looks like it's heading to the lower left. But remember, the stuff that's facing us, that stuff is going to head out and expand in all directions. So a chunk of that stuff that you see from that near arm of that loop is stuff that's going to whack us. So, flares are nothing to play with, man. I mean, they are actually really, really dangerous. So
they're beautiful.
They're beautiful. They're
Yes.
stunning. I actually have a solar telescope here, and I can look and see what's going on. I can see flares. I can see that stuff. And I'm telling you right now, it's like seeing everything in stop motion. You don't see anything moving when you look at the sun. You'll see this gigantic streamer, which looks like it wants to go, explode like this, but all you see is this. And to see it change, you have to come back like an hour later, and you'll see a little tiny change. Come back 3 hours later, it might be like that. Maybe a little more. So it takes time for these things to occur. So you recognize and appreciate the dedication that some of these scientists have to getting time-lapse information and time-lapse data to actually show you what's going on here.
You have a hydrogen alpha telescope?
I do.
Oh, cool.
Yeah, and I've actually had it mounted on the SkyTour Livestream East telescope for a period of time. And I'm going to do daytime solar observing, but I kind of gave up on it because I felt that the telescope, as nice as it is, it just didn't have the resolution I wanted to actually show it nicely.
Yeah, 40 millimeter. Is that a Lunt, I think?
A what?
A Lunt telescope? Lunt or Luntz? Lunt?
No. It was actually a Coronado instrument.
Oh, okay.
Coronado. What's her Coronado devices? What's her name?
I know who you're talking about. I think Lunt and Coronado may have actually merged.
Maybe they did.
And Meade bought them one time too. I just have a white light filter for my telescope, and you can't see the prominences or the loops, but sometimes really powerful flares are called white light flares, and they will show up in a white light filter.
Just like the Carrington event was a white light event.
Yeah.
So the solar flares occur sometimes in very high energy light, guys, and that light can be in the X-rays. You have soft X-rays, which are lower energy levels, and hard X-rays. But you get, like initially, the flares occur in several stages. In the first stage, you get a soft X-ray release. Okay, so the precursor stage. And then you get the actual event, which actually releases a lot of material. And then you can get hard X-rays in there, which are very high frequency light. It's the brunt of the flare. And then you have a decay segment of the flare where it actually kind of tapers off, but there's still material coming out. You know, you like that material coming out? That's kind of how it goes, right? So that said, I think it makes sense it makes sense to consider that when we take a look at these flares, we want to consider what light we're looking at them in. And in the light of hydrogen alpha, you might see it like this. All right. In X-ray, you might see it like this. All right. I don't actually have a white light image, okay, of a flare event, but that's just kind of not an oversight, but there's really not any that I've seen. I mean, you can see if you have a special filter on the telescope, you know. Yeah.
But when space observatories monitoring the sun, they look at multiple wavelengths constantly.
Yes,
like calcium and others.
That's correct. Yeah.
Yeah.
Yeah, and we're going to talk about that more. You know, we do have another break to go to. It's a hard break. I can't stop it. It's going to happen whether I like it or not. They'll just cut me off. Okay, but we're gonna talk about this some more, and we're gonna get to Tara as well. And Daryl, when we come back, I'd like to have you show people a deep dive. So
okey-dokey.
We will be back right after these words. This is Mark. That's Tara down there, and Daryl. We'll be back.
Hey members, the new KGRA-DB app is now available on iOS and Android devices. Gain on-demand access to any KGRA-DB programming. Download any show directly to your mobile device to listen or watch on the go. Go to the App Store and search KGRA-DB.
I don't want to talk about it.
I don't want to talk about it.
Families don't have to talk about everything, but they should talk about how to plan for an emergency. Get tips and resources to make your family's emergency plan.
Welcome to the new KGRA digital broadcasting website, thekgradb.com. Here you'll find great new content, including the KGRA Classics, great shows from our archives. You'll be able to see the show times and information so you can see what show is currently on air. The on-air live button. So just go to this section and you'll be able to hear the show live with exceptional sound quality. We also have the Vault section. Make sure to subscribe to get access to great content and special features. We have the make content for our latest news and events, so make sure to sign up and you can be part of our forum. So make sure to check out the new KGRA digital broadcasting website, thekgradb.com. We look forward to seeing you there, and we hope that you enjoy the new website.
And we're back. Welcome back, guys. And right now, we're going to leave the solar flares behind, and we will move forward with a different overview of the sky. And that is the one that I'm hoping you can do for us, Daryl. We call this segment the Deep Dive with Daryl segment, and we're going to take off into one particular constellation. So, Daryl, what constellation have we chosen for tonight?
Scorpius.
Scorpius, the Scorpion. Fantastic. That's a summertime constellation. Awesome.
I'm going to meander down that way. This is the usual sky tour thing.
Yep.
I'm going to start with current events and head over to Scorpius. So if you'll bear with me.
Sure.
Give me just a moment here to get set up.
Not a problem. Then Daryl's using the online version, I believe, of Stellarium. And there we go. That's fantastic.
Okay. Can we see that okay?
Absolutely.
Okay. Well, this is the view a little after sunset tonight, looking over in the little bit north of west, the west-northwest. I'm starting with this tonight because right here, Venus and Mars are in conjunction tonight. Like if you remember when Jupiter and Saturn were in that great conjunction last December, Venus and Mars are in conjunction right now. It just says Venus, that's Mars right next to it. And if you have a good west-northwest horizon, you can see these, but you'll probably need binoculars to see Mars. Venus is 200 times brighter than Mars right now, and that's just putting Mars to shame by comparison. Venus is brilliant over in the west-northwest after sunset. If you see it, there's no mistaking it. Venus is the brightest thing in the sky after the sun and the moon, and it's absolutely brilliant after sunset. I've been going out and looking on clear evenings lately, and if I don't see it at sunset, Venus is visible within 5 minutes after sunset, and it's really beautiful. Tonight, too, I wanted to focus on, if you can look, the moon is a couple of days past full, and it is sitting just to the right of Venus and Mars. You may also need binoculars to see it because it's very young. It's a very thin crescent. By tomorrow night, the moon will be up here to the upper left of Venus and Mars. Venus and Mars should still be close together tomorrow night, still in conjunction.
Hey, Daryl?
Yes, sir?
I think you meant just a couple of days past new.
What did I say?
Full?
Okay, yes, I'm sorry. It's just past new. I'm getting ahead of myself here. Sorry.
That's all right.
The moon was new a couple of days ago, and so it's just the barest little fingernail paring of a crescent moon right now. But you can maybe hopefully see it tonight just to the right of Venus. And by tomorrow night, you'll see the moon will have moved up there. And you'll see Venus and Mars will actually be even closer tomorrow night. So there. I'm going to be jumping around here some. Bear with me. It's not even dark here yet. And I'm going to set up for, let's see. Here we go. The next thing, before I back out in the sky, Leo is setting earlier and earlier every night. And he's standing on his head, his nose basically, by 10 o'clock at night. He's starting to set. There he goes. And you give it next week, it'll be there about 9:30, and the week after that, it'll be 9 o'clock, that half hour a week thing, or 4 minutes a day, as we slowly march around the sun. And Leo is going away. Okay. And followed by Virgo and the rest of the stars in the spring sky. And let me get situated here. We're going to wind up with the usual view looking south. There goes Leo and Virgo following. It's the Big Dipper. There's Polaris and the Little Dipper, Boötes and Arcturus, and Scorpius is well up by 10 o'clock now. Scorpius, actually, Antares is crossing the meridian just a little after 10 o'clock. You can see Sagittarius in the teapot to the upper left of Scorpius, and the Milky Way is cutting right in between them. The center of the galaxy is right about there. And by 10 o'clock at night, if you keep following that red line, which is the plane of the ecliptic, that's the path the sun and the planets pretty much take across Earth's sky. There is Saturn right there. It won't show it yet. I've got to go in closer. But there is Saturn, and we'll give it another hour. And hey, Jupiter is up by 11 o'clock at night now. Big and bright. You can't miss that. It's the brightest thing over in that part of the sky at 11 o'clock at night. It's a bright, creamy white color, and you can't miss it. But there's Jupiter, and there's Saturn. Still won't show it, pardon me. But tonight, we're going to focus on Scorpius, okay? And I'm going to zoom in on it, and Mark is doubtless going to share some images with you. There's Antares. Antares is the heart of the Scorpion. That star's name is Dashuba. That's the middle of the Scorpion's head, or his forehead. And you've doubtless heard me say before, if you go over to Libra, there is Zubanesh Shemeli and Zubanel Janubi. They just say Sigma Lyra there. But Zubanesh Shemeli and Zubanel Janubi, those are the southern and the northern claws of the Scorpion. Scorpius is one of the oldest, maybe the oldest of the constellations. And before there ever was a constellation Libra, well, Scorpius went all the way out here, where from his elbows, like out here, there are the tips of his claws right there, and what now constitutes Libra. So there's his claws, there's his head. Antares is the Scorpion's heart, and if you follow the tail down, there is Shaula and Lasath. Those names both mean stinger, and those are the stinger stars in the Scorpion's tail. We're going to zoom in now. Some people also, that little star, they draw a line to that. That's the actual tip of the Scorpion's tail. I usually see it there with Shaula and Lasath, though. And those are also known as the cat's eyes. They look like a cat looking at you in the dark. And now we're going to start zooming in. Okay. Mark took a really cool picture recently with the new setup on his telescope. It's a wide field view of this area. I'm sorry.
Yeah, no, I said, yes.
Oh, yeah. Mark got a beautiful picture of Antares, and right there next to it is M4 globular cluster. It's a beautiful cluster. It's one of my favorites. And there is another, I'm going to have to go in more. I bet Mark will show the picture. There is another globular cluster in his image right there, which is NGC 6144.
Yep.
When you see Mark's image, it's framed about here. And
want me to try it?
Sure.
Let me see if I can pop it in here. Okay, so you should see that now. You have Antares in the center, just left the center. It's very bright, so it gets these rings around it. Those are called star halos, and I'm trying to work to get rid of those. And to the right is what Daryl just said, Messier 4, a globular cluster. Check out all those stars. 40,000 stars, perhaps, on average, in globular clusters, maybe less, maybe more, depending. And there's the other globular cluster just above center. So that's what he's talking about. And right above Antares, that orange star, notice those little orange clouds that have some kind of weird-looking depth to them? That's real stuff. Those are clouds, interstellar clouds. And that's really just it's a fascinating area. And if it's, it is. It's beautiful.
It's called Rho Ophiuchi.
Above this is Rho Ophiuchi, which is the Rho is the Greek letter, and Ophiuchus is the constellation that's there, so it's Rho Ophiuchi. And that's a location where there is a focus, a concentration of this beautiful nebula.
It takes beautiful images too.
Yeah,
you'll see blues and reds and all sorts of stuff in there.
Sure. There you go, Daryl. Back to this. And we also have Alniat, remember?
Okay. Am I back on?
You are.
Okay. Let me go full screen again. I'm sorry, I had to go full screen to get this up good.
No, that's fine.
Mark is going to show another image of this star. It's called Alniat. It's another beautiful image. There's more nebulosity visible. And maybe he'll share that with us now.
Sure. Okay, this is Alniat. You see the lower center there. There's a star. And there's a beautiful nebula surrounding Alniat. And what's also visible is you see this has a filamentary structure to the upper left. There's a beautiful reddish nebula there. That is a hydrogen alpha region, H2, as we call it, H Roman numeral 2. Ionized hydrogen being ionized by a bright hot star will lose an electron. The hydrogen atom has one electron. It jumps off, and then it spontaneously rejoins as it loses a little energy. And as it rejoins, it falls to a specific spot in the atom where it releases red light. And that's what we see, the hydrogen view here. Up to the right, you see another star that's actually surrounded by more dust, as you can see by the black in there and the black area around that cloud. This is what's called a reflection nebula. It's actually operating more the way a blue sky works. It's really scattering light and creating this view. And then all throughout the image, you can see hazy cloudiness between Alniat at the bottom and that star pair at the upper right. And then just above and to the left of Alniat, you actually see another area that's a cloudy area. This area is full of dust. And it's just amazing here, and this was at this location where Sky Tour Livestream West is located. This was a 20-second exposure, 20 seconds, and we get dark nebula. That's unheard of. Okay, so this is just beautiful. And now, Daryl, I'm going to turn it back to you.
Okay, keep your picture up for just a second there, if you would.
Okay, sure.
Okay, take note, please, that red glow of the nebulosity around the star Alniat. That is the very same red glow that Mark showed you in those pictures of the sun and hydrogen alpha light. It's the same wavelength of light.
That's correct.
That's correct. And you can go back down. Let me go
and you are back
again.
All right.
Okay, and because we are looking in the general direction of the center of the galaxy there, we tend to get a lot of deep sky objects and a lot of M objects, Messier objects. There's another globular cluster right there, M80 is a globular. And I'm going to back out a little bit. We're going to follow the tail down now. When you see Scorpius in the sky, you'll see Antares. It's unmistakable. It's a bright orange star. And it's very much like Betelgeuse. It's a good supernova candidate. It's a red supergiant. It's actually a double star also. It has a very close secondary that's usually lost to view because Antares, the primary, is so bright. But you'll see sort of a fishhook shape from Antares, and that is the Scorpion's tail. And one reason I love Scorpius, it's one of those rare constellations that actually looks like what it's supposed to be. We'll get down here. That star's name is Sargus. There's Shala. There's Lasath. Okay. And, just above and to the upper left of the tip of the Scorpion's tail, here is M6, the butterfly cluster we've looked at on Sky Tour many times. It's really pretty. We thought maybe we had that in the telescope view the other night. I just saw this pattern. It looked vaguely like a butterfly. And also M7, these are both star clusters, open clusters. I think I've heard M7 sometimes called the jewel box cluster. It's really pretty. They're both really pretty.
Mm-hmm.
Let's see, that's all I've got for Scorpius. But there is the tip of the teapot in Sagittarius. Al-Nasl is the name of the star. That's the tip of the arrowhead that Sagittarius is shooting. He's aiming his arrow at Scorpius at Antares, he's about to shoot the scorpion, so the story goes. And the center of the galaxy is right off the tip of Al Nossel, right off the tip of the spout of the teapot. And we're going to back out now. Under Sagittarius, there's Corona Australis, which is called its southern crown. And above, you see the Milky Way going up. As we move through the summer here, you'll see Sagittarius as the Earth turns. Sagittarius will move over to the west-southwest or southwest, and it'll tip, and the Milky Way will be the steam coming out the spout of the teapot. And then over farther to the southeast, you'll see Saturn, and then you'll see Jupiter by 11 o'clock at night, big, bright, and beautiful. And to back out and to finish up, well, when you get back to the bigger view of the sky, there is Achille the eagle, and here is the summer triangle, or the big slice, like I like to call it sometimes. There's Deneb. Okay, that's the tail of the swan, Cygnus the swan, or there's the swan you can see. There's Deneb, the tail of the swan. Deneb is also the head of the Northern Cross, which is there, and there's Star Alberio, really pretty double. There's
My
Vega.
favorite.
Oh yeah, mine too.
Yeah.
There's Vega and Lyra, and when Mark shows you the Ring Nebula is right in between those two stars, right there. You can't miss it. It looks like a smoke ring floating out in space.
Yeah, I don't have the ring tonight, but I will have it on future shows.
There's the ring.
I do have an image for the Milky Way to show people what we saw when we streamed the other night, to give them an idea of what a 20-second exposure can show you for the Milky Way with the dark nebulae that we see. Like if Daryl, zoom out a little bit and go back to central Milky Way a little bit.
Excuse me.
Sure, and just take out the constellation art if you could.
Yeah.
Okay, so now if you zoom into the Milky Way area near the Sagittarius star cloud, that middle area, yep. Okay, that's good. Right.
I think we were right about there.
I do think so too. I think I actually found where we are on that particular night. Of course, it doesn't do us any good now because I didn't specify a location, but I will when I get a chance. But that's Stellarium's view, but this is the actual view of that location in a 20-second photo.
Wow.
Right, Tara?
Wow.
Look at the dark nebula going over the top of this image and arcing. And then within there, you see knots of darker, thicker, more dense material. You're looking probably at over 150,000 stars right there. Overall.
Oh, yeah. That was so much fun the other night. We started out, I forget, I think we'd been down to the lower left, and we saw a dark patch, and we started following the dark patch up, and
That's correct.
It just unreal. It was a dark cloud after dark cloud, and each one was bigger and better than the last.
Yep. And this was the final large cloud we saw, that arc. And I wanted to get a good photo of this so that we could identify where we were. So if we find it again, and I haven't been able to align the telescope properly, I will at least be able to tell the telescope its coordinates and its rough location. And then from there, we can get a good enough alignment so we can actually go to specific objects again.
Mm-hmm.
Because again, we do have a 2-degree wide field by 1.5 degrees. So that's a huge field.
Yeah.
You know? But there you go.
That was such a trip.
It was.
Well, I'm going to wrap this here, I think.
All right,
unless
Daryl,
there's something
thank
else you'd
you.
like to see.
Yeah, no, this is fine because Tara's going to tell us about the moon you talked about earlier.
Okie dokie.
Yeah. So this is fantastic. Thank you, Daryl.
Sure.
Yeah. And here's Tara now. Tara, Daryl mentioned the moon is a young moon, meaning it's only a small way into its cycle right now. And that means it's literally like 3.8% illuminated. It's so little illuminated. But, there's so much about the moon that people sort of don't think about. And you, being an artist, I want to get your impressions of what you see when you see a young moon like that in the sky.
Well, I'm kind of fascinated by it. I'm looking at a waxing crescent moon right now. Like Daryl said, it's just under 2 days old. This waxing crescent moon started on July 9th and it ends on July 17th. And the times that it starts varies by your time zone, wherever you are. But it's in the sky right now. And so the waxing moon occurs between the new moon phase and the full moon phase. So it's growing, right? It's
correct.
Okay. So when less than half the moon is illuminated, that's a waxing crescent, is what I understand. And so the shape that you see, like Daryl said, looks like a crescent or a fingernail or something. And the waxing crescent moon, it rises in the daytime and before noon, and it becomes visible in the day sky. And so it's most visible around sunset, and it typically sets before midnight as well.
Excellent.
Yeah. So the sunlit part is what's growing on a waxing crescent versus the waning where it's getting smaller and smaller. So the side that appears to be illuminated, it depends on where you live, of course. So if you're in the northern hemisphere, the right side is becoming larger and more illuminated. And if you're in the southern hemisphere, it's the left side that's illuminated. And in the past, a waxing crescent used to be called the new moon, from what I understand. But
it has a name.
Yeah.
It's poetic, and the artist in you might like this. When you see a young crescent moon, you'll often notice that the so-called dark part is actually glowing dimly. That's called Da Vinci's glow or whatever, something like that. But it's called the old moon in the new moon's arms. When you see the dim part, the unlit part, being held by the new crescent, it's called the old moon in the new moon's arms.
Hence the new moon term that you were talking about just there, Tara.
So is that the earth shine that's lighting up that little bit?
Yes, that's exactly correct. Yeah. See, let me explain earth shine, because I think, and Daryl, you could do it too, I'm sure. But
go ahead.
Okay, the earth shine is when you actually see the unilluminated part of the moon. It's not illuminated yet, but you see the moon still sees the earth, and the earth is still bright and blue, to the moon. So that light goes to the lunar surface from the earth and reflects back off the lunar surface, and we can see that dimly. We've actually done a lot of live streams where we actually overexpose the darker unlit part of the moon, and you can see the craters, and you can see the Maria, you can see these, the so-called lunar seas, and you can see all these things, even though it's not illuminated yet, right? And that's because of the fact that we're exploring the earth shine. It's also in that earth shine area where we can actually, if it were to happen, we would be able to see a meteor hit the moon if it hit. And we did catch that on that stream 2 Januaries ago.
We did.
Remember that, Daryl?
Oh, yeah.
And we actually saw a meteor strike the moon right at the height of the eclipse, the lunar eclipse. The moon was blood red down the lower left, and boom, we saw a bright spot that flashed. And that was a meteor around just over a foot or so across, maybe a couple feet, a little less in between. And it struck the moon. And, of course, it struck with such energy that it was immediately vaporized, and a bright light was generated when that happened. Of course, because when you take kinetic energy, the energy of motion, and convert it into instant stopping energy, now that energy is converted to heat. And that heat will, of course, glow at a certain temperature, brighter and brighter and brighter, depending on the temperature. And it glowed bright white for just a split second. It was really beautiful. And we were one of 5 or so groups on the planet that actually caught it.
Yeah.
Yep. And we're proud of that at SkyTour Livestream. Come to us if you want to see for all your meteor needs on the moon. But Tara's comments are all perfect and accurate, and very accurate too. So you may continue, Tara. I'd like to also share my screen to bring up some other things so that I can show them to everybody as well to complement what you're talking about.
Well, I can tell you that I always have an issue figuring out if it's waxing or waning.
Okay.
And so I know that waxing rhymes with relaxing. So I go waxing, relaxing. So the R for relaxing is on the right. So if it's illuminated on the right, I know it's waxing. And so
Huh.
if that helps anybody. But so the thing about the crescent moon, it's the moon's first step towards fullness after it's been in new moon. So there's been a lot of folklore. What do you do at this time of the year and stuff? And the crescent encourages positivity and faith. So it's a really positive time because everything's new and anything can happen. And it's basically like a call to action. It's a time to plant above ground crops, things that starting your goals, planting your goals and setting your goals and starting things, work on home improvement projects. And my favorite thing to do during this time of the moon is to adopt a pet and offer a loving home. So
that's pretty cool. I didn't know any of what you were just telling me.
Yeah.
That was pretty cool. Did you hear that before, Daryl?
I had not.
Yeah.
And there you go.
Wow.
And I've actually been to Tara's home in the past, and she has a menagerie of animals. So
I bet.
she must have been through a lot of
Once a
lunar
month.
cycles.
That's right.
I think we're coming up on a break.
Looks like we're about a minute in. Mm-hmm.
Oh. Where did Mark go?
I think we may have lost Mark, but we're going to go to break anyway. So
Perfect.
there he is.
There he is.
I'm here.
Hi, Mark.
Sorry about that. I know we're actually approaching a break time, so we'll be right back, and we're going to continue with Tara for a little while longer because she has some wonderful questions to share with us, and I would like to just show a couple more things about the moon when we get back. So we'll be right back.
Hey members, the new KGRA DB app is now available on iOS and Android devices. Gain on-demand access to any KGRA DB programming. Download any show directly to your mobile device to listen or watch on the go. Go to the App Store and search KGRA DB.
I don't want to talk about it.
I don't want to talk about it.
Families don't have to talk about everything, but they should talk about how to plan for an emergency. Get tips and resources to make your family's emergency plan.
Welcome to the new KGRA digital broadcasting website, thekgradb.com. Here you'll find great new content, including the KGRA Classics, great shows from our archives. You'll be able to see the show times and information so you can see what show is currently on air. The on-air live button. So just go to this section and you'll be able to hear the show live with exceptional sound quality. We also have the Vault section. Make sure to subscribe to get access to great content and special features. We have the make content for our latest news and events, so make sure to sign up and you can be part of our forum. So make sure to check out the new KGRA digital broadcasting website, thekgradb.com. We look forward to seeing you there, and we hope that you enjoy the new website.
Hey, welcome back. This is Mark with Tara and with Daryl over there. And we're here to bring you the finest in astronomical information and entertainment. Usually, if I do something crazy, is the entertaining part, right? So welcome back, guys. And I wanted to just share a little something. Tara was talking about the moon phase earlier, and she talked about it being a crescent, a waxing crescent. And this is what I actually wanted to show you, and I'm going to bring it up here. This this image, all right, which I'm going to full screen right now, is right there. Okay, this image is actually of that crescent moon. How do you don't see it yet, but you kind of do. There you go. Okay, this is from a website that's called the Lunar Phase and Libration website. It's really, really good. And it shows you exactly what the moon looks like for the start of our show tonight. And it also allows you to check out all the craters on the Terminator. And one of the things that I think Tara wanted to talk about, but hadn't yet, and Tara, you can jump in here, and mention it if you like.
Okay.
Is that we were talking about Mare Crisium. Actually, this is probably the most prominent thing you'll see at this current stage of the lunar phase. You'll see Mare Crisium. And it's basically a lava sea, and it's nice and round, probably formed from an impact that flooded this whole area. And if there were any craters here, they're forever hidden underneath old lava that overran them. Okay, but this is a beautiful website because you can see all the craters on the Terminator as you move along. Okay, and it gives you a view of them and kind of shows you what it looks like. What's interesting is it also shows you the Earth shine because here we're actually looking at the Earth shine here. Now, what's neat is when you look at this is the waxing crescent moon. So that means that this illuminated portion is going to grow larger. You'll see that these are the Apollo sites. The first Apollo site that you're going to see as the waxing moon reaches it is Apollo 17's site, followed by Apollo 11's, and then followed by Apollo 16 as the days go on. Then you'll see Apollo 15's site come into view, and then Apollo 14, and finally Apollo 12. It's really kind of a cool thing to watch the moon get more and more illuminated and see at a certain point when Apollo 17's landing site is available to look at and so on. It's really a lot of fun. Very, very cool. But one of the things I want to talk about is the shape that the moon has, that it changes from time to time. Not the phase, okay, but it has something else to do with the orbit that the moon has around the Earth, all right, being slightly elliptical. And it has to do with the fact that the inclination to the Earth's orbit is slightly elevated. And that causes things to happen to the moon. And if we look at this image, okay, we actually can see how the moon changes. This is a basically back-to-back showing months of the moon changes. You notice how it looks like it's wobbling?
That's very cool.
Right? Yeah, this is an image which shows you something called libration. That's L-I-B, like library, and then, L-I-B-R-A-T-I-O-N, libration. Okay, not liberation, but libration. It's liberation without the E. Okay, and you'll see that you see a little bit of the South Pole, and then later on a little bit of the North Pole, and then a little more of the South Pole. And you'll see a little more of the eastern horizon and then the western horizon on the moon. See, it's going behind, and then it's coming out again. What's causing that? Okay, well, it's two different forms of what we call libration. As the moon is going around the Earth, the moon is in a slightly elliptical orbit. And that slightly elliptical orbit around the Earth will cause the moon to sometimes lag a little bit behind or slightly ahead of the Earth. And that is responsible for this east to west drift that we see and the west to east drift. Now, that means we actually can see a little bit more of the moon, up to total about 59% of the moon instead of 50%. We actually see a few more percentage points on either side. It's pretty interesting. And that's the longitudinal version. That's the left to right. Okay. But you'll also notice that we're seeing a little bit of the north and a little bit more of the south. So why is that happening? That happens because the Earth's orbit and the moon's orbit are not aligned with each other. They're not parallel. The moon's orbit is elevated just a little bit to the Earth's. Okay. And that's actually called latitudinal or latitude libration. All right. Now, the moon's equator is actually tilted about 1.5 degrees from the Earth's in general. Plus, the moon's orbital inclination is about 5 degrees, all right, which means that it goes 5 degrees above and 5 degrees below, okay, our celestial equator. But in total, it works out to be about 6.5 degrees overall. Go ahead, Daryl.
It's tilted to the plane of the ecliptic.
Yes. Which is yeah, it's exactly right. Sorry, the plane of the ecliptic, which is the plane of the solar system, basically. And so the Earth is actually tilted on its axis, of course, because of the fact that our Earth is on a slight angle in the sky relative to the other bodies like the moon and so forth. That's why we have seasons. But this movie shows us the reason why the moon is actually changing. We see the east to west lag that happens because of the slightly elliptical version, slightly elliptical orbit of the moon. And you'll notice the moon's getting a little bigger and a little smaller, and then it gets a little bigger as it gets closer to us and a little smaller.
That's due to the ellipticity.
That's correct.
Of the orbit. Yeah. This is sort of analogous to the Earth's elliptical orbit around the sun and the motions that create the analemma, that figure 8 shape. You could say it's the moon's rate of rotation is constant, but its rate of revolution varies depending on where it is on its ellipse as it orbits around the Earth, which lets us peek around the edges like that.
That's right. That's right. And it depends. It depends where, where in its elliptical orbit it is, to determine how much lag ahead or behind of its previous position where the Earth is located. And that's interesting. But so the moon isn't just solidly facing us, you'll notice. Okay, there are other things going on, and those other things are called libration. And we have longitudinal libration, which is responsible for that east to west drift and west to east drift. And latitudinal libration is because of the inclined orbit to the Earth's orbit. And so it's above the plane of the ecliptic at one point, below the plane of the ecliptic at another, and thus we'll see a little more of the north, a little more of the south. But as it is, the moon is already 1.5 degrees tilted from the Earth's orbital plane as well. So it's not perfect as it is. So that gives us about a 6.5 degree overall inclination to the moon's orbit to us. And that's what makes this all happen north to south. East to west is because the elliptical orbit is doing its thing. But this is the lunar libration. And it's... Go ahead, Tara.
I'm sorry, Mark. I was going to ask you, so is the moon phase and the libration, are they in sync with each other? So at this time of the phase of the moon, next month, will the libration be at the same place as well? If that makes sense?
That does make sense. I understand what you're saying. And in fact, when you look at this, you'll see that the libration and the phase do seem to be linked, don't they? Because we're seeing it now. This is not a month after month. This is just this is an example from from October to November of 2007. Okay, but there's subtle changes that are made that the Earth is experiencing, and I don't think we would want to consider. I don't think we want to consider some of those effects that are going on in the background. Those are long-term effects, but in the short term, it's okay to think about the fact that this motion of the moon is the same each month. Okay. I have to go into something a little more detailed to talk about why there's some differences over time. Okay. But for now, yeah. And that's a good time to jump off now into your questions, Tara, for your Tara's Cosmos.
Oh, well, great. Well, thanks. That's really interesting. You were talking about space dust earlier, and I know you've discussed this, but I still want to understand what constitutes space dust, and how do you know it's dust and not just darkness that's behind something? How do you know that dust is in front of everything?
Well, when you actually take photos with a regular telescope, you may look at objects and they may look like a void to you. However, when you do an infrared study, you find that there's areas in the sky that actually have a lot of stars that you don't see because they're blocked by something. And so when you're looking in a particular direction, it'd be helpful if you could see me. If you're looking in a particular direction, okay, then you're going to have the heat from those stars approaching your detector. And if you have an infrared detector, you'll see, even if there's a dark pall of dust between you and the stars, you'll see those little pinpoints coming through. All right. You'll also see where that cloud is heated by those stars, perhaps if they're close to it or within it. And this is how we know that there's stuff there. We have other means. If you looked at it just visually, well, then we could look at our image that I showed you earlier of the Milky Way and say, well, how do we know? I mean, it's very possible then that what we're looking at is just a dark void. This would be considered like a void right there. But if you use an infrared telescope and you look at that dark void, you're going to see that there's something else. You're going to see that cloud has a different level of heat energy within it, which makes it a substantive thing, something that you don't get if you just have a void. Okay, you'll see that there's going to be dots of stars behind that dark stuff, indicating that it's something blocking. And we see that a lot in astronomy. We actually find this to be true everywhere. So when we look at the universe and we see these dark clouds like this, okay, we know that those are blocking or are mingled with the stars that they are occluding.
Back in the old days of astronomy, before photography, they often called them voids. They didn't know there was stuff inside there. That is, that they were clouds. They called them voids.
That's right. In this book here that I have, this is the book that Tara has, the book that I also have digitally. This is Views of the Architecture of the Heavens in a Series of Letters to a Lady. This beautiful book comes from the 1800s. The images inside are covered with paper that you move, and then you can see the image. It really talks about voids. It talks about the voids in this, and that's really interesting to see that. So it's going to be kind of cool because I think 100 years from now, we're going to have an awful lot more information about the dark nebulae and what's going on inside of them. We know inside the Orion Nebula, for instance, that there's star formation going on. We know inside of many of these hydrogen regions that there's star formation going on. And we know that these areas are also prone to planetary formation because we see proplyds, which are these little blobs of material that's self-condensing, gravitationally condensing, blobs of dust. And as it gets hotter and hotter in the center, maybe a star will form in there, but then maybe at some point a planet will also form at some point down the road. So that gives you an answer as to how we know about this dark stuff, Tara.
That's really cool.
Yeah. And I know
That-
you've got more questions.
Well, that book you were just showed everybody. What
Oh,
was
yes.
neat about part of that book was when they're just first seeing the first images of nebula, and they're describing it as just like fuzzy stuff, and they don't know what it is, and it's just really cool to see
Well,
how it has
yeah.
changed.
And everything off the Earth is something out in the firmament.
Yes,
I felt
yes.
that was really cool. That everything was the firmament.
Yes,
No.
it
Can I
wasn't a
jump on
universe.
Can I jump on the space dust thing for a second?
Yeah.
Please do. Yeah.
We're going to focus more on the solar system, the dust in our solar system. This story's been going around lately. When like we see the zodiacal light and the Gegenschein and stuff like that, dust in our solar system, they used to say it was just general, cosmic debris orbiting the sun. Nowadays, they're saying they think a lot of that dust comes from the planet Mars.
Actually, I
You,
think I've heard that story. But was it because of the collision theory?
I'm not sure. I haven't got it all down in my own head yet, but
Okay.
I've seen that repeated several times recently. They think a lot of the dust in the solar system is coming from Mars.
Okay. I haven't looked at like the latest stories, and I remember that's sort of I mean, you say now they're thinking, but actually that was something that was floated a long time ago, and I actually didn't see any evidence for it personally, so I just sort of didn't dismiss it, but I just set it aside and said, well, more evidence will show if that's true. So if there's more evidence now, that'd be interesting to see.
I'll have to look into that. I'll get back with you about that. Sorry for the interruption, Tara.
No, that's fine, Daryl. I'm sure
No worries.
she always enjoys being interrupted.
This is all good experience for me. I'm learning so much all the time. So kind of changing the subjects a little bit, black holes. You talked slightly about those. Can we see what's on the other side of a black hole?
Well, black hole's a sphere, so on the other side of a black
Right.
hole, it's going to look the same. What you mean is,
Like
if
what's
you could go-
behind it? Like if
if you
there's
go
a
into a black hole, you're wondering if
no,
you see
well,
something through it or
no,
within
like
it.
no, not necessarily. I mean behind it. So there's a black hole at the center of our galaxy. Can we see the stars that are on the other side of that black
Oh,
hole?
okay. Actually,
So how can we see that type of stuff? What's back there, and how? Because does that tell you how big the black hole is?
well, no. The way here's the thing: by watching gravitational interactions between a black hole and something that it's orbiting or that's orbiting it, we can detect and figure out the masses of the objects involved. However, what you're looking for, if you could see what's behind a black hole, the way to do that might be through another property that gravity has afforded us. And that's called gravitational lensing. And we can see that when you actually have a star that's between us and some object, sometimes that object looks like a ring of light because the star's gravity has distorted the object and gravitationally lensed it. And that's something that a large gravitational field can do as well as a high mass star. In fact, planets have been discovered because of gravitational lensing as well, using that same technique. So a black hole could technically create a gravitational lens for what's behind it. All right. So like say there was a big galaxy behind a black hole, then that galaxy's image, if we looked at it, would be very distorted. And we would figure out eventually that it was distorted because there was a black hole between us and that galaxy that's distorting the image of the galaxy. Because you see, light follows the curvature of space. So when you actually distort space by causing the space-time fabric, just like fabric or cloth, if you distort that fabric enough, light's going to follow those really intricate curves. In space's case, the gentle curves of that space that's been distorted. And when it follows those curves, you see the result to your eye, to our telescopes. And it might look nothing like you expect. We've seen things like that. So I think it's a really interesting concept, you know.
There are some really cool videos on YouTube of when you're flying close to a black hole or around one or even falling into one, how the view changes and you're seeing stars on the backside and stars from all around you. You know that as you get closer, it distorts the view
Yeah.
more extremely. It's really cool videos to watch.
Well,
And
go ahead.
well, and then an extreme case of what you're saying too is like the Einstein crosses and stuff, where a foreground galaxy distorts what's behind it, and we actually see multiple images of a background galaxy
Yeah.
around the foreground galaxy.
Yeah.
And it's the same thing. It's gravitational lensing.
And a possibility, which I've floated to a few people in astronomy, is that when we see a particular galaxy called a ring galaxy, which looks like it's just a ring, is that just a favorable position of a supermassive black hole in front of a galaxy that's not a ring, but it's made to look like a ring because of the black hole distorting the light coming from the galaxy and passing by the black hole.
Cool.
So I don't, I mean, there's not enough research on that to know the answer to that, but that's just an idea that I've had for a long time, that these really, really, really rare ring galaxies might be a geometric thing, something caused by the geometry of a local nearby black hole to it. But hey, I'm sure you have more.
Oh, more questions. Okay, I do. I'm wondering, I have a lot of questions.
I know.
Once you get your telescope aligned, the Sky Tour live stream west,
Yes.
what are some of the first objects you want to show us? Because now you can drive to them.
Well,
I want to know where we're going to go.
I was able to drive to them until a solar flare hit. And then, so now I'm lost with it. And because you live there, I'm thinking I'm going to teach you how to align a telescope and have you go do it.
Okay.
On the other hand, I may not have
it.
to. I know you would. That's
all that coming.
Yeah, right. Well, you want to see something? Fix it. No, I am just kidding.
Tara, get a business card printed up and put consultant under your name. Then you get to charge him $200 an hour.
Awesome. I love it.
Yeah, if that's the case, then I guess we'll just be spelunking the universe then from now on. No, the truth is that the objects I want to show people are objects that are the most spectacular for that location. For instance, the Veil Nebula, a supernova remnant, which is just stunning and spectacular. And in a 2 degree by 1.5 degree field, you're going to see more of it. And it's going to be 25 times brighter than it ever has been in our East telescope imagery. And it's been pretty bright here. I mean, we've actually seen some really, really nice, bright objects here. And it's going to be even brighter. I'd like to show the Eagle Nebula, which is absolutely gorgeous and bright. I'd like to show Messier 33, which I think is this guy right here. This is Sky Tour Livestream's East's image of Messier 33, full of globular clusters that we can actually see with that telescope. And we're going to see it much brighter. It's going to be a little smaller, but it's going to be beautiful. The Andromeda Galaxy, okay? This was taken with a wide field view, not in east, but not in west, rather, but in east here. We did this with a 5-inch refractor on board the telescope. Just beautiful. And I want to show people that. I want to show people the Lagoon Nebula. This was done at east. And this is going to be so much more elaborately detailed in Sky Tour Livestream West. The Trifid Nebula. Okay, this beautiful tri-lobed nebula, the Eagle Nebula, which is where the pillars of creation are. We're going to see those in so much more detail.
Mark, I hate to interrupt, but it's time to go.
Oh, I think it is, isn't it? Oh yeah. Okay. Awesome. Well, you know what? That's a good place to stop off because we'll actually be back. Ladies, gentlemen, boys and girls, and all you people out there, you have Daryl to blame for the fact that we have to hang up. No, I'm just kidding. It's my fault.
Blame Bill.
I know. It's okay. We're not blaming anybody. So, guys, thank you for joining us for another Sky Tour Radio. Thank you, Tara. Thank you, Daryl, for being here. Sorry, Amanda, you don't feel well. We'll see you next week for sure. But we'll be back next week. This is Mark D'Antonio for Tara and Daryl signing off. Good night,
All
everybody.
right.
Not